So will the three given sides should the three given sides form a triangle? Well, let's think about this visually. And I have the luxury of using my Smart Notebook here. So we've got a side length of 14, and we've got a side length of 3. And I'm not 100% sure that this is going to work this way, but right now, if I just put the three sides together, here's what we know. This side is 11, this is 14, and this is 3. Now, if I hinge them, now assuming I can move this without changing the length, what would happen here is the side length of 11 has to meet with the side length of 3. But as I get closer and closer, we actually kind of run into a little bit of problem. They're gonna meet exactly at one spot, but that one spot actually ends up being on the line itself, and the reason why is 11 plus 3 is 14. So that's the visual explanation of what we're going to be doing today. But in general, I read the comments here, and one that stands out is Josh had mentioned. He said, doesn't any two sides of a triangle, so any two sides, have to add up to be greater than the other side? And that's the idea. That's exactly the theorem we're going to be looking at today. It's called the triangle sum theorem, and you may have heard of it. I think I hinted at it a couple of times this trimester. Actually, we're going to save this. I'll just put a little note here, because every once in a while we tend to lose a kid or two during class. If you tend to get distracted, we are actually going to do this at the end of the hour. You have to sign up for a new DeltaMath class today, and I'll teach you how to do that at the end of the hour, right before we show you the homework. So your homework tonight is on DeltaMath, but you do not have access to it until you sign up for that new class. And I'm going to walk you through the steps on how to do that, but it's going to be at the end of the hour. So make sure that you're with us for the entire hour and you don't fall asleep or disappear. Okay, so we're going to go fairly quick today. We don't have a ton to do, which means you should have some homework time in class here to go through. All right, so here's our learning target. You don't need to write this down, but we have basically 3 things we're going to study. And I think this order is a little mixed up, but we're going to look at the triangle inequality theorem. That's what we just hinted at. And that tells us that if we have 3 side lengths, we can determine if it makes a triangle or not. And then we're going to talk about the distance formula and the midpoint formula. But we're going to actually teach you other ways to do it as well. So not just memorizing a formula and using it. We're going to think about this logically and be able to solve these pieces. So I would like you to write this down. I'll give you some time. By the way, we don't really have a title for this. It's not one section out of our textbook. It's officially a couple of things that we just didn't have time for in first trimester, but they are important. And now that we've kind of used some of them, we're just going to throw them in there. So I don't love today because it really doesn't sync with everything that we've been doing. It's kind of a makeup day for us. But that's just the nature of distance learning right now, is we're trying our best here to get everything in. So this is called the triangle inequality theorem. And all it says is that the sum of the lengths of any 2 sides of a triangle is greater than. So the sum of 2 sides has to be greater than the length of the 3rd side. And officially, we should check all of the relationships. In the warm-up we showed, we found very quickly that 3 plus 11 was not greater than 14, which proved that it actually formed a straight line instead of a triangle. So that's kind of the logic we want to use. And you can see in their example, they test all the sides. And this is more of a visual piece, but you can see that the length of A plus the length of B is definitely going to be greater than the length of C. And then you can see that if you add A and C together, that they're definitely going to be longer than the length of B. And same thing, if I add B and C together, they're definitely going to be longer than the smallest side. So mentally, we want to just check all three relationships, but technically, as soon as you find one that doesn't work, it can't make a triangle. Okay, so we're going to use this theorem just to determine whether or not three sides can form a triangle. If it turns out that they can, then we could extend our thinking to determine if it was acute, obtuse, or a right triangle by using the converse of the Pythagorean theorem like we had talked about. So we're going to do a couple examples here. You don't need to write down basically all of this. I kind of just want you to see it. These are directly from DeltaMath, and that's what your homework's going to be like. So just to grab some quick problems, I want you to try this, and we can do a Zoom poll here really quick. Let's call this A, B, C, and D. And your job is which of the following sets of numbers could represent three sides of a triangle. I'm going to get a poll put up here in just a second. As soon as I get there we go. So you should be able to see that, and whenever you're ready, go ahead and respond. All right, because this is multiple choice, we're really just looking for the one pair that actually forms a triangle, but I would kind of approach this as, well, right away, if I do 10 plus 21, well, 10 plus 21, that's 31, and 31 is not greater than 33, so that would be a false expression, so it can't be A. If I do 13 plus 15, it's 28, and 28 is not greater than 30, so it's not B. If I do 14 and 20, that's 34, and that is not greater than 36. So now I have to check, and we should kind of confirm all the pairs. So right now, 11 plus 26, or 11 plus 16 is 27. 27 is greater than 24. So that works. But I should also check the other pairs. So what about 16 and 24? That's definitely greater than 11, because if 16 is greater than 11, then adding more to it would be. And then the last piece would be 11 plus 24 has to be greater than 16, and since 24 is greater, we know for sure that that works. Okay? You don't really have to show a lot of work from this. I just want to make sure that you aren't just checking one relationship and then stopping. You should check more than one. So this is the kind of question that just says which three could represent a triangle. I'd like to do the same thing now with this question. Which of the following sets could not represent three sides of a triangle? And we'll do a poll again. I think I can relaunch the same poll. Yes. And let's call this A, B, C, D. Another 15 seconds. Okay, so let's take a look at this one quick. Um, Here's my hint for you is, and it's not always going to work, but it mostly does. Check the two smallest sides first. Do the two smaller sides add up to be greater than the third larger side? Well, 29 is definitely greater than 26. I'm going to just check those first. 10 and 17 is 28. That's greater than 24. 10 and 21, that's 31. 31 is greater than 30. But then we get 6 and 12. 6 plus 12 is not greater than 18, right? It's equal to. So it can't be equal to, because if it was, we'd get 6, 12, and 18. And the only spot, if we swung this side down and this side down, they would meet right here because 6 plus 12 is 18, and it would form a line, not a triangle. So the correct answer was B. All right. So that's the first part. Okay. That was just a triangle inequality, and it's literally just adding sides together and seeing if they're bigger than a third side. And you should check all the relationships until you find one that doesn't work, or if they all work, then it forms a triangle. The next thing we're going to do is talk about the distance formula. Now, I should be careful because it's not officially the distance formula, it's the idea of length. How long is it, or what is the distance between 2 points? And we're going to look at that on a graph first, and then we're going to look at it analytically or algebraically. So I actually don't want you to write this first piece down. I literally put this up here so I could, as a reminder to myself, to show you what DeltaMath is going to ask you to do. So let me show you this first. Okay, don't write this. My job is to find the distance between the two yellow points. Well, what they want you to do in this first part is we actually are going to find distance not by just counting or doing it. We're going to relate it back to what we already know, which is the Pythagorean theorem. So what you have to do, according to the directions, is graph a right triangle with 2 points forming the hypotenuse. Those are the two yellow dots. And then using the sides, we want to find the distance of the length between the 2 points in simple radical form. So I'm going to just show you this quick. And here's the tricky part. It says click twice to draw a line, and then click on a segment to erase it. So what we have to do is we have to draw a triangle. Now I can draw it this way, or I can draw it up or down. It doesn't matter. But if I click on it once, that's going to activate the line. And then when I get it to where I want to go, I click on it again. And now I have to click again. So you have to form the right triangle, and then it says, now you may answer the question. So now I can go ahead and actually tell me what is the length of leg 1. So here's 1, 2, 3. All right, well, that has a length of 3. And then length here is 1, 2, 3. So think of this as kind of like your run and your rise, or I could say rise in my run. I'm going to go over 3 and down 3. But when we talk about length, length is always positive. All right. Let's see. You may only graph 2 line segments. Oh, I think I clicked on something wrong. Now, you may notice this as an isosceles right triangle. It's a 45, 45, 90. So actually, I don't even need to show any work. This is 3, 3. We know that this length is 3 square root of 2. Now, you do have to answer in simple radical form, so you got to use the radical when needed. If you don't reduce the radical, you could have everything else right and they won't give you the answer. So there you go, we got it. So I just wanted to show you how you create that right triangle first. And then let me show you another example here. Don't write this one down because we're going to do this again on the next slide. So let's say I got basically the same problem except for I'm at 2, -3, and 7, -7. So they gave me the yellow dots. I formed the rise and the run, and I have to determine the legs. Well, all we're going to do here is literally just count. And that's the reason why we use this rise over run, is because I can count length going vertically or horizontally. So start here, there's 1, 2, 3, 4. So this is a length of 4, and notice it does form a right triangle. And then I start and count 1, 2, 3, 6, 7, 8, 9. All right, so I've got a leg of 4, leg of 9, and then I need to find the length, which is the hypotenuse, and that gives us the Pythagorean theorem. So we're going to go right back to all that work we just did before. And what is this? That's 97, I think. And then I got to see if 97 can be divisible by any of those perfect squares. So I'm going to just kind of make this list: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. Okay, hold on. And 9 squared. And I mean, clearly, these bigger numbers aren't going to go into 97 evenly. But, and I'm pretty sure not many of these do. I just kind of quickly checked. I checked to see 16 doesn't go in, 9 doesn't go in, 4 doesn't go in. I know 25 doesn't, and I know 36 doesn't, and the rest of them are too big to check. So this can't be broken down, which means my answer is just the square root of 97. That's as far as we can go. Some people like to use that factor tree and break it down. All right. So we're going to show you 2 methods for doing this problem. Now, technically, you don't need to draw this graph if you don't want to. I'd like you find the distance between the 2 points in simple radical form. Go ahead and try this with method 1, just creating a right triangle. And if it's easier for you to view it, I'll actually draw the right triangles in, so that way you don't have to waste time drawing it. But our job is to figure out what's the length of the hypotenuse. And there's my right triangle. Let's take a look here. So I just kind of quick counted. We go up 8 and over 6 to form the right triangle. So 8 squared plus 30 plus 6 squared is 64 plus 36, which is 100. And then when I take the square root, this is a nice friendly answer. Square root of 100 is 10. Now I should note, because in Algebra 2, by the way, when you do take the square root, you get a plus minus. You actually get two answers, but we're only focused on the positive one because we want distance. Distance or length is always going to be considered positive. So just keep that in mind. Okay, well, how do I do the exact same problem so we know what our answer is going to be? And I like doing this method first because you're going to see there's a reason why we get 64 and 36 and where those come from within this distance formula. So you probably have seen this before, but definitely write this down. We are going to use the distance formula, which is just the second method for finding the length between 2 points. What we need, though, is we need the location of those 2 yellow points. We need them in terms of x and y. So I'll give you a second to write this down, and then we'll work through it together, just so you know everything that's set up there. All right, for us to use the distance formula, we need to know the location of those 2 points. And if they're given a graph, I would leave them on the graph. But a lot of times, they're just going to give you the points written out. So then our job is to take those points that are written out and just say, well, the first one is my first point. So let's call it x1, y1. And the second point is x2, y2. Now the nice thing is it doesn't matter which group I call the ones and which group I call the twos, as long as it's x2, y2, and x1, y1. So it doesn't really matter. And same thing here. You can flip these around. You're going to get the same answer as long as whatever you call the ones are in the same order, and same with the twos. So here's what I usually do. Is I say the distance equals the difference of the x's plus the difference of the y's. So I kind of, and when I teach, I do this all the time, but I use like this blank template in black because that's always going to be the formula. And then we just say, well, okay, what was x2? I labeled it as 9. What is x1? I labeled that as 3. And then what did I label y2 as? y2 I labeled as 3. What did I label y1 as? Now this is where you got to be careful. We're subtracting a negative right here. So it's subtracting of a negative, which is much better thought of as addition. All right, and then it's order of operations. Simplify what's inside the parentheses first. 9 minus 3 is 6. And then 5 plus 3 is 8. Now notice something here. 6 squared plus 8 squared. Wait a minute. Didn't we just do 6 squared plus 8 squared? And then didn't we take the square root? This right here is the exact same thing as what we just did with the Pythagorean theorem. So I do want you to make a connection, is the distance formula is just a pre-written out formula that came from the difference of x's and the difference of y's. That's where the 8 and 6 came from. So these two methods are basically the same thing, they just appear different. And if you can make that connection, it just kind of builds your conceptual knowledge. All right, so then what do we have? We've got the square root of 6 is 36 plus, I said that wrong. 6 squared is 36, 8 squared is 64, and notice it's the exact same work. If my answer wasn't a nice perfect square, then I would have to break it down and reduce, just like we did. So those are two ways that you can do the distance formula. Here's how and why I would use this one versus method 1. If they just give me the 2 points, it takes a long time to set up an accurate graph so you can count the rise over run and make a right triangle. So if I'm not given a graph, I'm going to use the distance formula. If I'm given the graph, I'm not going to do this. I'm going to make a right triangle and do Pythagorean theorem. So I'll use method 1 if I'm given a graph, and method 2 if I'm just given the points. All right. We're going to shift gears now to our final concept for today. And this one, we actually have 3 different ways to learn how to do it. And you may remember the idea of finding a midpoint of a segment. Now, unfortunately, I'll just tell you this, we did not get into the constructions this year. It was the hands-on learning, and we weren't confident that everybody could get or have a protractor or a compass, and it's really hard to teach via distance doing that. So we scratched that, and one of the things we ended up losing was this visual concept of what is a midpoint. Well, let's think of that first. The idea of the midpoint is exactly what it sounds like. If we ever ask you to find the midpoint, we're asking you to find a middle point, and a middle point is an XY pairing. So the midpoint is not a single answer, and that's the thing I just want to make sure you're clear on. Distance gave me length. Length is a single answer. Midpoint is a location, an X and a Y coordinate. So don't add those two together. Your answer is a point. Okay. So we're going to go through and we're going to do 2 methods here. I personally like the table better. Actually, I like the graphical side better, which we maybe could have done that one first, but it doesn't matter. All right, so let's say this. Find the midpoint of the segment with the following endpoints. Well, let's look at this. We have x's, right? Here's an x1, and that's a y1. Here's an x2 and a y2. So what point is exactly in the middle of these 2 points? Well, we can do this through a table. So I'll give you a second to get caught up to where I'm at. But what we're going to do is we're going to take those points and put them in a table. 6, -4 is 1 point. And then -2, 0 is my next point. And what I'm looking for is I want the point that's in the middle. So I'll give you a second to, actually, why don't you try that? I'll give you a second to write it. And can you figure out from what we're talking about here, what point would be in the middle? Okay, well, let's take a look at this and let's really focus on the word middle. Well, think of just your x's. If I'm at 6, if I go from 6 to -2, right? What did I do? I ended up subtracting 8 total points, right? If I go from 6 and I take away 8, I'm going to be left at -2. But I don't want to go all the way from an endpoint to an endpoint. I want to go half of that. So instead of subtracting 8, I'm going to go half of 8, which is 4. So 6 minus 4 tells me 2. 2 is the halfway point between 6 and -2. And then we're going to take that same idea If I go from -4 to 0, what did I do? I added 4 units. But I don't want to go from endpoint to endpoint. I want to go halfway. So half of that is to add 2. So -4 plus 2 is -2. And there is my midpoint. Okay. I like the table, and you're going to see why on the next example, or one of the next examples, I should say. The second method is the formula. And look at the way this formula is written. It has a comma. It's the first answer is my x's, and the second answer is my y's. And I might even change this to match that color. Let me. Okay. So if I want to use the midpoint formula here, all we're doing is taking the average of the x's and the average of the y's. So we're going to go back to what we labeled x1 and x2, and I'm literally just going to add them together. 6 plus -2. And then we'll do the same thing for the y's. So y1, y2, we're going to add the y's. So I like to think of this as the average, because if you add two things and divide by 2, that's the average of the x's and the average of the y's. So then I end up with -4/2 and +4/2. And there still is that comma in between, right? Our answer is not a single number. It's the x values, 4 divided by 2 is 2, and then it's the y values. And notice we get the exact same answer as we did in the table. It's up to you. Sometimes it's beneficial to use the formula. I honestly think the table is a lot better. But you get to pick which method you want to use. And I apologize. Okay, if you're watching the video, I forgot to hit record. Here's what we did. Plot your 2 points, A and B. Draw a line connecting A and B. And then look at the rise over the run compared to A and B. So I went down 10 and over 6. But I want the midpoint. So instead of going down 10, we're going to go down half of that, which is 5. And then instead of going over 6, we're going to go over half of that, which is 3. And that puts us exactly at the middle point of this line, which location is -4, 2. And that is the location of the midpoint. All right, last problem, very last problem, is what if we give you the midpoint and one endpoint? Can you find where the other endpoint is? Now, we could do this graphically. I could give you a graph and you would draw it, and I might show you that here, but we're going to look at solving this with the table. So find the the midpoint of AB is M, and that's at the location -2, 1. If coordinate A is -3, -5, what is the location of coordinate B? So you could graph this if you want, and that might really make this nice, but we're going to pretend we don't have a graph, at least to start. Now we're going to look at our table. In my mind, this makes this problem much faster. And think about how we set this table up. Right? The table, we usually put the endpoints, and then right in the middle was the midpoint. Well, now, if I know that the point A, the endpoint, how do I know this is an endpoint? Because it goes from A to B, and M is right here in the middle. So if I wanted to draw a line, M would be in the middle. But A is the location -3, 5. All right. B is at the location -2, 1. And my job is to find location B. What is the endpoint? Well, we're just reversing our thinking from the last formula. So what do I do to go from -3 to -1? Well, I added 1, right? -3 plus 1 is -2. And then what did I do to go from -5 to 1? Well, I went from negative to positive, so I'm adding, and those are 6 units away. So I added 6 to go from -5 to 1. So that's how I went from one endpoint to the middle, but since this is the middle, that means to get to the other endpoint, you do the exact same thing. And so I added 1 here, and then I added 6 here. So -2 plus 1 is -1. 1 plus 6 is 7. So then we would just say coordinates of B are -1, 7. To be honest, I would use the table. It's much faster than taking the time and graphing it. But a graph would be the same thing. I'll do a very quick sketch of a graph. It's not going to be accurate, but I think it'll give you guys the idea. So you don't have to write this part. But here's kind of how I would approach this problem. Right? If I have a graph and I go from A to M, that's my midpoint. Well, how did I get there? Right? What did I do? I went, wrong button. How did I get there? I went up 6 and over 1. So up 6 over 1. Well, if I continue to go up 6 over 1, that will bring me to this location of point B. So that's graphically, that's how you would do it. It's basically the reverse of what we did before. Okay, so now is the time where I need every single person to open up DeltaMath. And I'm going to show you how we make this change. And actually, maybe I should show you first so you can just do it very quickly. So here's what I got. If I go to DeltaMath and I just log in, we need to change our settings from first trimester to our second trimester. That way you don't have all that work from first trimester in there and it doesn't look super confusing. So when you log in, you're going to go to Tools. And then you're going to go to Manage Course, Login and Course. And then you have Teacher Class Information. All you have to do is hit Edit. And there's a new drop-down menu. And we are 4th hour Accelerated Geometry, Mr. Strub. If you have anything else checked, you only want to be checked in 4th hour, second trimester, and then hit Save. And when you do that, your information is saved. And then when you go to DeltaMath, you will see the assignment that I have posted up there. And I actually don't even, looks like it's not posted yet. So I will make sure that it's posted. You shouldn't need a code if you're already in my class. So let me show you again. If you go to Tools, Log in, you don't hit Add Teacher or Access Code, hit Edit. So if you go right next to, you should have Mr. Strud period 4, and then hit Edit, and then the drop-down menu. Let me know if that's not the case. If it's not the case, it does say you need a code. Okay. Well, let me show you the code then. I have to sign into my other account. That's why we're doing this now all together, is in case things do pop up. All right, my teacher code. I will take a picture of it. So if you need a teacher code, it is right here on the screen, 416534. And then make sure you select 4th hour accelerated geometry 2nd trimester. There should only be one 4th hour option on there. Oh, I can see why there's no assignments yet. I never changed the post date. I actually posted it at the wrong time. Okay, so right now you should be able to, once you get logged into the new class, you might have to refresh your page because I just made the assignment available. And you should see it. It should be titled something like, what was it? Distance formula, midpoint, triangle, inequality. And then you could click on that, and it looks like we got a handful of people already signed up. Okay, so here's what I'd like you to just know. Your homework tonight is DeltaMath. It's the distance, midpoint, triangle, inequality. You're going to submit a screenshot to Schoology when you're all done, so showing me that the final slide was completed. If you got all that and you have no problems logging on to DeltaMath, then you can leave. But right now, I only have 1, 2, 3, 4, 5, 6 people who are officially logged in. So you 6 people can leave, and I don't want you to leave until you officially have signed up. Okay, Caitlin, hit refresh, and it should work. All right. Anybody else having issues that needs me to walk through another step?